did you can actually probably exit out of this because then you get a code. Like once this goes to our page,
Okay.
just exit out of this tab because then you won't get any code.
Gotcha. That is sharing.
Yeah. Start notes for the start.
Sounds great. Yeah. It's actually running. Let's try that through for time.
So I like about Ubuntu. It's always running.
What's up?
That's what I love about Ubuntu. It's always running. It's just
Right.
root.
Yeah. Let me resize my giant screen resolutions here. That's better. Resize my screen so that people can actually see it.
Yeah, it's
Okay, so, yeah, so I guess if you wanted to just keep an eye on time, and if when we get to the end of the demo, just because because we can run through the data stack slides in a couple minutes if we need to, but if we need to skip it, just ignore whatever. Yeah, I need to share. It's 10:30. Do we want to start or do we want to wait?
yeah, do it.
Yeah, let's do it. Wait, how's that look, CJ? Can you see my screen?
Yes, it looks beautiful.
Right, thank you.
Data engineering is beautiful. And just to remind you guys too, we might have some questions coming from the live stream, so I'm going to do my best to go back and forth on that.
Cool, yeah. Just let us know. Thanks.
Sounds good.
Hey everybody, it's Guy Emparum from Data Stack Academy. How's everybody doing? Today we're going to do another in our webinar series, this time about Airflow, and we're going to focus particularly on creation of DAGs or directed acyclic graphs for Airflow. So let's get right into it. Presentation overview. We're going to talk just for a couple of minutes as an overview about Apache Airflow, what it is and why we use it. And then we'll talk a little bit more about DAGs, or directed acyclic graphs, and we'll give you a hands-on demo of that and why we use Airflow as data engineers. And if we have time, we'll talk a little bit about data engineering as a career. Okay, so Apache Airflow. Airflow is used for data pipeline orchestration. Orchestration meaning to organize our different computational and processing tasks. We, as data engineers, we use Airflow a lot. We like it because it's source and it's based on Python, which is the language working with data. It has a lot of different built-in connectors for things like Spark and other things that we use to process data. It has a lot of capabilities for scheduling, letting us schedule all the different tasks, processing things that we need to do. And it's got, can interface with a lot of different execution engines like I said, Spark, or different other things we use commonly as data engineers. And there's a whole network of plugins and extensibility that you can add functionality to Airflow. So between everything Airflow can already do and all the plugins, you can use it pretty much to do anything. Okay, key concepts in Airflow. The main thing we're going to talk about today is what's called directed acyclic graphs, or DAGs. Those are the main computational structure or data structure in Airflow. DAGs are a representation of processing that have nodes and connections between the nodes. These pictures at the beginning of the presentation are a couple examples of diagrams of DAGs. You can see here there's different ordering of processes and different dependencies. Things have to happen in a certain order. Directed acyclic graphs are a really good way to represent any kind of processing that we need to do. And so that Apache Airflow is based around those. And we're going to talk a little bit more about using DAGs and how to design them and what that looks like in Python.
Pretty much. So that means just we can just like make very complicated workflow processes, right? That depend on each other, and even like goes back to the beginning. So
yeah, and we'll show you a couple examples, some more examples of these, so you understand what those look like and what kind of DAGs you might work with in Airflow. And then real quick, a couple of the basic Airflow things. Airflow lets us, the basic unit of DAGs is tasks. Obviously, that's the sort of atomic unit of how we do our processing. Airflow also gives us operators and sensors. Operators, we have like Python operator, Bash operator, and sensors is like file sensors, so we can interact with different kinds of data and other things. Scheduler and XCOM and variables, these are kind of more advanced Airflow concepts. So we're going to skip over those for now and go straight into talking about DAGs. In a DAG, the vertices represent our tasks and the edges represent the connections between tasks. When we talk about a directed acyclic graph, the fact that it's directed, or we go through it in one direction, the fact that it's acyclic, meaning there's no cycles or loops, means that we can reliably go through the graph from one side to the other and have our processing happen in the order that we need to without getting stuck in loops. And that's obviously a very useful property. DAGs in general give us a sequence of tasks and dependencies between them. A lot of times when we have different processing tasks that we need to do, the input of one process depends on the output of a previous process that's run before. So those things need to happen in a certain order, and one has to finish running before another one does. And DAGs let us specify those dependencies so everything can happen in the appropriate way. And DAGs are defined as Python code, and we'll take a look at that once we get into the demo here in a minute of what exactly that looks like. Okay. Let's get hands-on with this. We're going to talk in particular today about Dag Design. So give me a minute here and I'll get into Airflow and we can take a look at some example DAGs. Okay, so Airflow is great because it gives us this nice browser-based interface. When we log into Airflow, the first thing we see is this list of DAGs. There's a lot of different example DAGs that are built into Airflow. So let's just take a look at a couple of just basic DAGs here. I'll just pick one out of the list. This is a relatively simple DAG. You can see it just has a few tasks in it. So this is a task where we have something based on the date time. There's two different branches, two different processing tasks. This is a relatively common form of a DAG. If we look at something a little more complicated, you can see that wait to click here. that most of the time, a lot of times we're using relatively simple DAGs, but DAGs let us specify complicating tasks or tasks of sort of arbitrary complexity. We can have all sorts of different tasks with different interdependencies if we need to. Here's an example of a much more complicated DAG. This is more complicated than we typically would use, but a lot of times when you have really complicated data pipeline operations with different ETL stages and things like that, this is the kind of thing that you need, and Airflow lets us build those and manage them. So let's go back and look at, in particular, a DAG that we built for DataStack Academy and for our course. Give that 1 second to load. Okay, so the first thing when we go and take a look at a DAG is we can get a couple different views. There's the default tree view here, or we can also get the graph view. And these give us a couple of different ways to see and understand our DAG. So this is a DAG that we built for the DataStack Academy bootcamp course. And this is what's happening here is that we're reading a lot of different airline related data from several sources, checking to make sure that it's all there, and then we're going to do some processing with it. So you can see here in this row, there's several different sources. There's aircraft data, airline data, etc. We're checking for the existence of all these different files, and then once this files present check passes, there's an init storage stage that sets up our database. There's a populate stage that actually puts the data in the database, and then there's some cleanup at the end. So this is an example of some very common things, kind of tasks that we do as data engineers. So this is the graph view of our DAG. Let's go back to the tree view for a minute. You can see that the tasks are the same, but the tree view gives us a little bit different presentation, so we can get a different way to view and understand our DAG. And Airflow also gives us this great view of previous instances. When we've run our DAG, we can see what tasks have failed. We can get a lot of information about that process. We can also, in Airflow, schedule the running of our DAGs instead of just running them manually. And this view gives us a lot of information about that. So let's talk a little bit more in detail about the design of DAGs. So this file sensing, this DAG that we're looking at that loads some data and from files and copies into a database. DAGs in general in Airflow are specified with Python code, and we can see Airflow gives us, as part of the interface, a way to look at the Python code for our DAG. So let's walk through this just really quickly so you can see the general structure of the code that we use. As is typical in Python, we have some imports at the top. Airflow provides us some different libraries to use, so we need to import the operators that we're going to use, in this case, Python operator, file sensor, and the dummy operator is something that lets us kind of lets us group tasks logically, so that makes it a little bit easier to organize our DAGs. So we import this stuff in some of the Airflow utilities. We're also importing a couple of handler classes that we wrote for our own airspace data. And then after we do our imports, we set up some basic logging. We define a couple of utility functions. There's a function that loads data from our configuration YAML file, and a couple of these other utility functions here. In particular, the main thing we have is init storage sets up our actual database storage. We're using BigQuery in this case, so you can see that this init storage lets us choose between BigQuery or a local MariaDB database. And then populate actually does the copying of the data. Once it's loaded from files, populate actually puts it into our database of choice. And then cleanup here does a little bit of archiving at the end, make sure our files are clean. And then the main part of our DAG is you can see this syntax, this with DAG as Dag Syntax. So let's take a couple of minutes to walk through this, and you can see how the different parts of the code correspond to the DAG that we're looking at.
So those functions were your tasks, like all the different tasks in your workflow. And this is like, now you're showing the glue, how you define this in Airflow to be as a DAG, right?
Exactly, yeah. So these functions up at the top, most of these functions are our actual processing tasks, and those correspond to, we'll see how those get called in down here in our DAG.
And I see they're Python operators. So that means in Airflow, they're just Python code that you've written. Of course, there's like in Airflow, there's other operators too, right? So if you have like a Spark job that you want to kick off, there's a Spark operator. and et cetera.
Yeah, bash operator if you need to do just general system calls or whatever. Yeah, exactly. Okay, so let's walk through this a little bit. So you can see our init, populate, and archive. These are the main steps in our DAG after our data, after we pass the file present check. So let's go back to our view here a minute and just refresh our memory. We're loading some data, and we do this check to see if the files are present, and then we have an init storage step and a populate step and a cleanup step. So let's look back at our code, and we can see that those functions, the init and populate and cleanup, are defined up here. And then inside this with DAG as Dag syntax, we are making use of those functions, those processing tasks that we defined up here. We declare those in this case as Python operators. And this is the part of our DAG file where we actually call those individual processing functions. So we have init, pop, and archive are the three main processing steps that happen after we load our data. And this, you can see here at the bottom, we have this loop. This is the part of the loop that reads our files, makes a file sensor for each one. And then what we have down here at the bottom, and we'll talk a little bit more about this, is how we specify our dependencies. So if we go back and look again at our view, our DAG view here, you can see that obviously by the ordering of this and the direction of the arrows, we set up a particular order that we want these tasks to happen in. And that's also a set of dependencies, meaning that we only want to start each subsequent task when the other one is finished. And so dependencies are a way that let us specify that ordering and what we need to happen first before other things can happen. So let's go back and look at our DAG code here, and we can see that down here at the bottom, this syntax with the arrows gives us the ability to specify, this is where those dependencies are specified. And we can see that ordering that we've used from the visual view. We have our file system check that goes to the init step, goes to the population step, and goes to our archive step. So this is the part of the code where that is coming from in our DAG. So when we run this, I'm not going to run it in real time, but when we run this, Airflow gives us this great view of what's successful and what's not. We can see which steps are running. If we need to, for example, if we need to take a look at the logs, Airflow gives us the ability to do that too. Airflow gives us a ton of information about all our processing steps in one place. Airflow is super powerful. That's why we use it a lot as data engineers. So this is just one example of a DAG. Again, Airflow lets us specify just about any kind of processing task that we can imagine. And this is a pretty typical example of something we do all the time as data engineers.
So we jump into, so I just want to make clear that how you kind of code these tasks and the DAGs, like you can code those in any IDE that you like in VS Code. And all you need to do is put that DAG code inside the DAG directory of Airflow, right? So as long as, like, even if you have a symbolic link or something to your code, to your project that has all the DAGs defined, Airflow kind of goes through your main.py and figures out that there's a DAG definition there and actually loads that automatically. So then you can see it in the dashboard, right?
Yeah, exactly. That Airflow makes it easy because you just have a DAGs folder wherever Airflow is installed, and when you put py files in that folder that correspond to DAGs, they show up in this list when you run Airflow. So it makes it really easy to see all the DAGs that you're working with. Anything else you'd like to say, Parham?
No, that was it. Yeah, and I really like that you show that you can see the logs and everything here too. So it's nice. It's a really nice way to visualize like all your DAGs here. You can see all the previous executions as you showed and see which tasks exactly failed at which level. So you can see in this view here, obviously you were developing in that January timeframe, and you can see there's a lot of yellow and red. And once you guys got things going, you kind of see the greens coming up later there.
Yeah. So Airflow, you can see how powerful Airflow is, and this is why Airflow is kind of the go-to orchestration tool for data engineers. We use it all the time. There's in Google Cloud, there's Google Cloud Composer, which is Google Cloud's version. So Airflow is definitely a big part of the data engineering ecosystem out there, and we love it. We're big fans of Airflow. Do we want to do that?
That's great.
All right. Well, thanks everybody for watching. Keep staying tuned for these weekly webinars that we get into hands-on demos and show you how to do some data engineering tasks.
Yeah, I think that was great. Thanks a lot. That's a good basic just information about Airflow, how you can use the Airflow UI, of course, and how you can use the Python code to define these tasks. We'll have other webinars coming up to kind of get into the more detail and get into the detail of like creating the DAGs and coding the tags, maybe using other operators and other sensors. That's really the power of Airflow. Airflow has a lot of these built-in operators that they're task operators. So again, for launching, for example, cloud functionality, cloud services, for launching like Spark jobs, for launching batch operators, different data engineering tools that we use, they're all built in. But you also have these sensors. So the sensors are a great way to sort of trigger your jobs, to sense for events happening. Then that makes Airflow very powerful to be much more event driven and being able to respond to events that are happening in our company. Of course, like we use the file sensor here. There's other sensors, that are out there. And the other thing that I like to bring up too is the Airflow, the support behind Airflow. So there's of course, there's a big company called Astronomer.io who is supporting Airflow commercially and supporting development, the community development of Airflow. And they have actually a marketplace. So they've built a marketplace where anybody can go and extend the functionality of Airflow. That's the other big power that I like to talk about. It's very easy to extend Airflow to build your own operators, to build these sensors. And on this marketplace, there's tons of, again, other operators, other DAGs, even pre-built DAGs that you can use as a template and kind of get started. So that's a place to check out. Of course, if you want to know more about us, we're Data Stack Academy. We offer a data engineering training and a data engineering bootcamp. If you go on Data Stack Academy, you can find a lot of information about our bootcamp. That's datastack.academy or datastackacademy.com. And please engage us. We love to hear from you. There's tons of ways to engage us. There's our social media links are posted there, but also you even have our email that we're going to post at this webinar. You can engage us directly. We love talking about data engineering.
Yeah. And CJ, it looks like we have a question. Go ahead and ask it if you don't mind.
Yeah, so we have a couple questions. First, the current example is an ELT architecture, correct?
Yeah, ELT or ETL. You see, so ETL stands for extract, transform, and load. ELT is extract, load, and transform, and those are, you see those terms used sometimes somewhat interchangeably. But ETL or ELT is a common data processing paradigm in data engineering. So I would say this is an example of this is an example. Yeah, of some ETL. We're extracting some data from files and doing a little bit of processing and then loading into a database. So yeah, this is one example of some ETL. Yeah,
I would say it's mostly, so to me, ETL and ELT is where you do most of, in ETL, you do most of the processing in Python and outside of the database, right? Mm-hmm. So in your execution environment outside in ELT, you will do it inside the database. In this DAG, actually, we don't have too much of processing.
Right, there's not too much proper processing here. Yeah, this is more of just an example, but yeah, the general format though is the same. Yeah.
I think it's good to note that you can do both in Airflow. Of course, Airflow has the concept of the workers. So Airflow has a scalable number of these worker nodes where they execute Python code. So you can use those to do ETL. if you want to use the power of those workers to do pure like processing in Python, you can do that. But of course, you can just use like a BigQuery operator. You can do, you know, an operator where you just send an SQL to the database and let the database do the processing for you. Yeah.
Okay, we have another question from Tessatora9. When should we expect to see additional content on DAGs? Apparently, we like this so much.
That's great. Yeah, so we will start. We're planning actually the next series of webinar. We're going to do much shorter webinars, but kind of back to back. So we will pretty soon we will have a whole Airflow series where we would do you know, Airflow in 7 days per se. So every day we would teach a new concept. Look forward in our Eventbrite and on our website for our upcoming webinars. It should be within the next month or two.
And if you have more questions about DAGs, feel free to reach out to us. We'll give you an email address here in a minute, and because we love talking about data engineering, so if you have specific DAG questions, we'll be glad to answer those.
Yeah, I would say as far as the timing on those, we're kind of just prioritizing on what's the most on demand, like, you know, where we get most of the demand for the topics. You know, we have a number of different topics that we like to talk about. So if you like Airflow, if you like to know more about Airflow, just engage us and we'll prioritize that first. But it is actually, Airflow is probably one of our top ones.
Yeah,
Airflow,
yeah.
Docker, Cloud Functions, serverless, those seem to be the high-end demand categories.
Okay, one thing that I think, because since we start so on time and in our world, it's kind of hard to get to the places where we need to be right now. So I kind of wanted you guys to, I want you guys to tell us a little bit about your background, since we do have people that are interested to know. So yeah, Guy and Parham, data engineers, experts in the field. How'd you get here?
Want to go first?
You go for
it. So I'm Parham. My full name is Parham Parvizi. A lot of people just call me Par. I'm one of the founders of Data Stack Academy. I've been a data engineer for a while. I started my career in a company called Talent, which a lot of people might know now. When I joined them, they were maybe 10 or less than 10 folks. So I was one of their maybe their first technical guy in the United States or in North America. And that really grew my career. So I was with them for a while, helped them expand to over 1,000 people company. Then I got connected with big data kind of early on and worked for one of the early big data vendors. Then I switched most of my career to Hadoop and big data, and then from there actually switched my career into the cloud. So just been sort of lucky enough to follow the trends, I would say, and within an industry. Currently, I mostly just highly specialize on the cloud, and I'm a cloud data architect, data engineer, and even to get more specific, I probably specialize on GCP and Azure. I started my career on AWS, but I've kind of gravitated more towards GCP and Azure now. And just love learning every day, love learning the new technologies, and love talking about data engineering as a whole.
Yeah. So my background, I'm Guy Cutting. I'm one of the members of Data Stack here. My background, I started out kind of a conventional, more of a web application developer background. I did web application database development for at least a decade, and always really enjoyed that. Worked in Cold Fusion, PHP, Java, a number of different languages. And then when I started hearing about the big data thing, and then a little bit later about data science, I got really interested in that. So I kind of reinvented myself a little bit. Went back to school and took a little bit more of like the mathematical side of and computer science side of things, and got more into some of the mathematical theory and then in the data science side. So I did more on the data science side of things for a few years, and worked as doing some consulting, as a contractor for some different companies, and really enjoyed the data science thing. But as I was doing that, I was realizing that a lot of what companies really needed was data engineers. That term is kind of more recent, and now a lot of companies are realizing how important that role is. So after doing the data science thing for a while, I kind of pivoted back to data engineering, which I realized that is sort of what I'd been doing for a while, but even though I hadn't called it that. So I started off as a web application developer, and then did the data science thing for a while, and now I've landed in data engineering, which is a great role. I really enjoy it. I like working more on the back end and doing the data infrastructure. So, I think data engineers it's a broad skill set. So having a background like that, where you have done a number of different things, is really useful. I think that's something that you see with a lot of data engineers for sure.
I didn't know you did cold fusion too.
Yeah,
that's
20 oh gosh, almost 25 years ago now.
Yeah. I know. I used to do some of that myself to go way back.
Yeah.
Yeah.
Back in my day.
I remember when JavaScript was actually just brand new.
I know. I remember that too. Yeah.
So see, us doing this actually leads way to us even learning more about each other. So we do have one other question is, are there possible code along sessions in the future?
Oh, that's a great question.
Great question.
Yeah, we've been really thinking about that, and we've used this platform that we really like in a couple of workshops, the Collaboratory.
Mm-hmm.
I think that's a great platform. We definitely will hope to launch that. If you haven't used Collaboratory before, it's Google Jupyter notebooks pretty much. So it's a really easy way to share and duplicate these notebooks. You actually get a Python execution environment on the Google Cloud, and you can easily share that. We've been thinking about using that, and also just using, just open code along format, where we would post our code on GitHub. This code actually, or the code that we're doing for the webinar today, we'll host it it is hosted on GitHub, and we can send the link.
Yeah.
So we can totally do that. But going forward, this is a tool that we've kind of identified. If you guys have any other recommendations for us, we really we always look forward to see tools that enable that code along, that collaborative environment. We love those. So if you have any recommendation, tell us.
No, we appreciate the question. The data stack, our bootcamp is very much focused around that peer programming model, and it's probably the best way to learn. And so we appreciate that question, because that's something that we're really passionate about, and that we want to get people doing and get people having fun with the data engineering skills. So if you're interested in that, then we'll make sure to bring some code along into some of these sessions that we're planning. Yeah.
I'd like to also mention too, this is we're kind of figuring this out as we go as well. So even if you have a platform, like we switched to YouTube Live, and I think YouTube Live is a really good platform to these live sessions. But if there's we've also thought about Discord or other channels where we could, maybe they're better suited for those, kind of code along live environments. So if you also use another platform for live sessions, we'd love to hear that as well. If you have any suggestions for us, kind of experimenting with those as well. I think YouTube Live is great, but is less of a feedback from that perspective. Sometimes we could think of other channels that could be better. Those are great questions. Yeah, we would.
Yes. So we are, we don't have any other questions, but and it looks like our time is coming to a close. If you guys have any closing things that you'd like to talk about before we let everybody go out of our amazing class.
Yeah, just keep a lookout, on for our upcoming webinars. We'll send you updates fairly soon. Those updates will be on our website. We're actually revamping the website fairly soon, so it'll be easier to see our upcoming webinars there. And check out our course. If you're interested in Data Stack Academy, our actually cohort is starting on Monday. We have another cohort starting in August. Please go ahead and get connected, and we'll love to see you in class.
Actually, we just had a really great question. Not Luck just asked, would love to hear a comprehensive explanation of data engineering day in the work life and how can one excel in the data engineering field. So I'm going to send this over to you guys so that you guys can get it. I'll ping you on Slack with this question so that you can answer that.
I would, yeah, I would love to answer that. I can send you that answer definitely in an email in a much closer format, but I would love to do like a little blog or even a little video on that one, and where we would talk about that, maybe another live session. I know we have some previous recorded webinars on our YouTube channel. So particularly there's one that's data engineering as a whole, or explaining data engineering as a concept. Check that out, but I would love to talk more about what data engineering day-to-day life entails and talk about
that. If you look at our YouTube channel in particular, there's a data engineering as a career recorded webinar there that has a lot more information about exactly what you're asking, which is about what data engineers do, kind of learning tracks to get into that. So there's some information there already. And Parham, if you want to give your email address, maybe if for somebody to get in touch with you.
Yeah. So my email is Parham, Parham, like Parham, at datastack.academy. Send me an email. I would love to talk more about that. I can definitely respond to that in a more detailed email fashion, but that's something I would love to put together a blog about very shortly, or just a short video. Awesome. Thanks a lot, CJ.
Thanks, CJ.
Thanks a lot for joining, guys.
Thanks for all the questions.
Yeah. We'll see you later.
Take care. Did you hear anything about the breakfast?